Well, you're back. Good to see you. This is recording 1C to go along with instructional recording 1C for Section 8.2, Unit 8, Chapter 8, Mathematics 2200. We'll model situations and solve problems involving systems of equations. Example 1, the sum of two numbers is 10. The difference of the square of the larger number and the smaller number is 32. If x represents the larger number, that's an important point, and y represents the smaller number, another important point, which system could be used to find the numbers? Let's pick things apart here a little bit. The sum of two numbers, we've called them x and y. The sum x plus y is equal to 10. So that tells us our first equation must be x plus y equals 10, or some rearranged version of it. So for example, if I brought the 10 over here and the y over here, I'd have x minus 10 equals negative y. So it doesn't rule out A, and it doesn't rule out C. Next it says the difference of the square of the larger number. The larger number is x. And the smaller number, the difference means we're going to subtract. So it's x squared minus y is going to equal 32. So our system of equations should be x plus y equals 10 and x squared minus y equals 32. Let's see if we have that there. We've got x squared minus y equals 32 right here. And if we rearrange the first one, we have x minus 10 equals negative y, so that's okay as well. So C is the correct answer. Example 2. The right triangle shown has a perimeter of 24 centimeters and an area of 2y plus 14 centimeters squared. Algebraically determine the values of x and y. So we've got two things to consider here. Perimeter first. Perimeter is found by adding up all the sides. So we know that 2y plus x plus 3 plus x plus 5, that has to equal 24. Let's simplify that a little bit. We've got 2y plus 2x, and I'll bring the 3 and the 5 over and subtract them from the 24. That gives me 16. I can divide everything by 2, and I've got y plus x equals 8. Now remember, for the triangle, the area is base times height divided by 2. So we have x plus 5 times x plus 3, x plus 5 times x plus 3, that's our base times our height, is equal to the area, but we're told the area is 2y plus 14. Whoops, I almost forgot my divide by 2 here in my formula. Now to make things a little easier here, rather than divide this side by 2, I'm going to bring this 2 over and multiply it by the 2y plus 14. So I've got 2 instead of 2y plus 14 equals x plus 5 times x plus 3. Now I distribute this 2 in here, and I've got 4y plus 28 equals, when I do FOIL here, or Benny binomials, as you may have seen me do, x squared plus 8x plus 15. That's what I've got there. A little bit of simplification, and I've got 4y equals x squared plus 8x. 15 minus 28 will be minus 13. Therefore, we have the following system of equations. Y plus x equals 8, and 4y equals x squared plus 8x minus 13. Coming over to a new slide, we have to choose a method to solve. I think I'm going to work with elimination on this one. Let's see. First of all, I will bring the x over to the other side. I've got negative x plus 8. And I leave the second one alone. So I've got this result. Now I want my y's to eliminate, so I multiply the first equation by negative 4. The second equation I leave alone or just multiply it by 1. So I have negative 4y equals 4x minus 32. And in the second equation, I've got 4y equals x squared. Oh, maybe I need to work on lining up my like terms a bit more. There we go. X squared plus 8x minus 13. I now add those two lines. 4y, negative 4y and the 4y are gone, so they make 0. Equals x squared plus 12x minus 45. Almost forgot my x there. Now we can solve that by factoring. I can factor that as x plus 15, x minus 3 equals 0. That results in negative 15 for one possible value and 3 for the other possible value. Now in this problem, don't rule out that negative 15 just because it's negative. Let's see what it does back here. Negative 15 plus 3 is negative 12. Uh-oh, that's no good. That's why we rule out the negative 15. It would give us a negative side length. So that one's inadmissible. We got x equals 3 is the only one we need to worry about. And we substitute that into our first equation, either form. And we get y plus 3 equals 8, so y equals 5. That's all we were asked to find. When solving problems, define what your variables represent. In our examples here, the variables were already defined for us. We interpret the sentences in the problem to write two equations, solve the system, interpret results, determining if there are any inadmissible solutions, and state your final solution.